Uh, Good evening. This is a lecture on fluid mechanics. In this video, I am not going to discuss any broad topic. I want to mention only one thing that in fluid mechanics course, you might have observed that we always talk about whenever we whenever we are going to derive equations, means governing equations relating fluid motion, we always talk about fluid element. And somewhere you might have observed that somewhere we use force is equal to mass into acceleration. That is Newton's second law of motion. Force is equal to mass into acceleration. F is equal to m into a. And somewhere we use force is equal to rate of change of momentum. Many students get confused about this. In one case, force is equal to mass into acceleration. In another case, force is equal to rate of change of momentum. Which one is correct? Or in which case we should use which form of Newton's second law of motion? First of all, I want to mention that the most general form of Newton's second law of motion is force is equal to rate of change of momentum. Yes, this thing was stated in the second law of motion by Newton. Force is equal to rate of change of momentum. So, say force is denoted by F, mass is denoted by m, velocity is denoted by v, and time is denoted by t. So, we can say that force is equal to d dt of mv, where mv is the momentum, mass multiplied by the velocity. So mv is the momentum, therefore what is the rate of change of momentum? You take differentiation of mv with respect to time, means d dt of mv. So this is the most general form of Newton's second law of motion. Now, if the mass concerned in the problem is a fixed mass, means if mass is a constant, mass does not vary with time. If this be the case, if mass does not change with time, then in that case, you can take that mass m outside the derivative sign, outside the derivative. Okay, when mass m is constant, then that d dt of mv can be written as m into d dt of v, means m into dv dt, or m into dv by dt. And dv by dt is nothing but acceleration. dv by dt or dv dt is nothing but acceleration. Therefore, it becomes mass into acceleration. In the left hand side, what was the force? Force F is equal to mass into acceleration. But if mass is not a constant, in that case, you have to take care of rate of change of mass also. Because d dt of mv can be written as m into dv dt plus v into dm dt, means dm by dt, means rate of change of mass with respect to time, also that thing we have to consider. So in many of the books of fluid mechanics, it is not clearly mentioned there that which type of mass they are taking. As fluid element. So wherever in the derivation for the governing equations of fluid mechanics, if fluid element is taken as a fixed mass, as a certain matter, as a certain fluid, as a certain mass of fluid, in that case you can directly write force is equal to mass into acceleration. There is no problem. If the fluid element is of fixed mass, means here your system is a fixed mass. But if your system, which is chosen for the derivation of a governing equation, is of a fixed volume, okay? Because you know that system is defined as a certain quantity of matter or a fixed region in space upon which attention is focused for the analysis of the problem. That way you have studied the definition of a system. So whenever you are taking your system as a fixed region in space, means fixed volume. Fixed region in space means fixed volume. Here system is what? For our fluid mechanics case, your system is now the fluid element itself. So whenever you are taking the fluid element to be a fixed region in space, then in that case, the mass of the system or the mass of the fluid element may not remain fixed. Yes, it may not remain fixed. If during the course of the flow, density of the fluid remains constant, okay, then there is a chance that within the fixed volume or the fixed region in space, the mass of the fluid remains constant with time. But if density changes with time, then within that fixed volume, mass may not remain fixed. Within that fluid element, there will be influx as well as outflux. Influx means mass which is leaving the fixed volume, or that is mass which is leaving the fixed volume is efflux or outflow, okay? And mass which is going inside the control volume, inside the fluid element or the control volume or the fixed region in space, that is influx or inflow, okay? So if they are same, the rate at which inflow and outflow are taking place, the rate means time rate. The time rate at which the inflow and outflow are taking place, if they are same, then in that case, mass remains fixed, otherwise not. So in general, what happens? Mass may not remain fixed. In case of a fixed region in space, mass may not remain fixed. So since mass may not remain fixed, that means mass is varying with time. So in that case, you have to write Newton's second law of motion as force is equal to a rate of change of momentum with respect to time. That is ddt of mv. That way, you have to take care of the governing equation. Otherwise, there will be blunder mistake. Okay? It is a very serious issue. It depends upon which type of fluid element you are taking for your mathematical deduction. Okay? So this thing always you keep in your mind, which type of fluid element is being considered for the analysis. Whether it is a certain quantity of matter, whether it is a fluid element of fixed mass or not. Okay? So, and one more thing I want to add to this, that whatever be the choice of your fluid element, resulting equations are always same. Resulting equations are always same. But if you take fixed region in space as the fluid element, and if you use the concept force is equal to mass into acceleration, then there will be error. And that is a mistake. Okay? Mistake will be where? In case of generalized equations, where everything is variable. In case of generalized equations, what happens? Everything is variable there. And in case of special cases, something remains constant, something varies. You have such ideas. Anyway, so always take care of the fluid element before starting your mathematical calculation for any problem of fluid mechanics. Okay. In this class, only up to this. Thank you. In the next class, I'll show you one example, taking different types of fluid elements.